I'm thrilled to welcome you all to today's Java tutorial session. Whether you're new to programming or looking to enhance your skills, you've made a fantastic choice by joining us to explore the world of Java. Java is a high-level, object-oriented programming language, developed by James Gosling and Sun Microsystem in 1995. It is platform-independent due to write-once-run-anywhere principle. Java finds extensive applications across diverse sectors, ranging from enterprise software to web development, mobile applications, desktop applications, robotics, and gaming applications. As you can see on the screen, we have a basic Java program laid out for us. In this program, we have a class named Simple. Within this class, there's a method called main, which is the entry point of any Java program. Inside the main method, we have a single statement that prints Hello Java to the console. The public static void main, string args, method. This method is where the execution of our program begins. Let's break down each component to understand its significance. Firstly, the public modifier indicates that this method can be accessed from anywhere. Next, the static keyword is crucial. It allows the method to be called without creating an instance of the class. Now, what does void signify? It's the return type of the method, indicating that main doesn't return any value. Main is the entry point of the program. Then we have string args. This is the parameter that main accepts. It's an array of strings, typically used to pass command line arguments to the program, and printing Hello Java in console. Now let us discuss about the different features of Java. Java is simple, object-oriented, portable, platform-independent, secured, robust, architecture-neutral, interpreted, high-performance, multi-threaded, distributed, and dynamic. Java is simple and easy to learn and understand. It has a straightforward syntax and clear conventions, making it accessible for beginners and experts alike. It has removed many complicated and rarely used features, for example, explicit pointers, operator overloading, etc. Java uses automatic garbage collector to remove unreferenced objects. Now we delve into a fundamental aspect of Java programming, encapsulating the essence of modern software development, object-oriented programming, commonly known as OOPS. Object-oriented programming, or OOPS, is more than just a coding paradigm. It's a methodology that streamlines software development and maintenance by adhering to certain principles and rules. These rules govern the organization of code, making it more efficient, scalable, and manageable. Now, let's delve into the basic concepts of OOPS, which form the bedrock of Java programming. Objects are the fundamental building blocks of Java programs. They represent real-world entities and encapsulate both data and behavior. Class. A class acts as a blueprint for creating objects. It defines the properties, attributes, and behaviors, methods, common to all objects of that type. Inheritance. Inheritance is a powerful mechanism in Java that allows a class to inherit properties and behaviors from another class. Polymorphism. Polymorphism enables objects to take on different forms or behaviors based on the context in which they are used. This is achieved through method overriding and method overloading, allowing for more flexible and adaptable code. Abstraction. Abstraction involves hiding the complex implementation details of an object and exposing only the essential features to the outside world. Encapsulation. Encapsulation is the bundling of data and methods that operate on that data into a single unit. Portable and platform independent. Java programs can run on any device or operating system with a Java Virtual Machine, JVM. You write your code once and run it anywhere, which saves time and effort in development and deployment. Java code can be executed on multiple platforms, for example, Windows, Linux, Mac OS, etc. Java code is compiled by the compiler and converted into bytecode. This bytecode is a platform-independent code because it can be run on multiple platforms. That is, write once and run anywhere where. Secured. Java takes security seriously. It includes features like bytecode verification, encryption, and access controls to protect against malicious attacks and ensure the integrity of your applications. With Java, we can develop virus-free systems.
No explicit pointer.
Java programs run inside a virtual machine sandbox. Robust. Java is robust because it includes built-in error handling mechanisms, strong memory management, and strict compile time checks to catch bugs early and prevent crashes during execution. There is a lack of pointers that avoids security problems. Java provides automatic garbage collection which runs on the Java virtual machine to get rid of objects which are not being used by a Java application anymore. Architecture neutral. Java doesn't favor any specific hardware or system architecture. It's designed to work seamlessly across different platforms, abstracting away low-level details and providing a consistent runtime environment. Java occupies 4 bytes of memory for both 32 and 64-bit architectures in Java. Interpreted. Java code is compiled into bytecode, which is then interpreted by the JVM at runtime. This allows for platform independence and flexibility, as bytecode can be executed on any system with a compatible JVM. High performance. Java strikes a balance between performance and portability. It includes features like just-in-time, JIT, compilation, optimized garbage collection, and efficient memory usage to deliver fast and responsive applications.
Multi-threaded.
A thread is like a separate program, executing concurrently. The main advantage of multi-threading is that it doesn't occupy memory for each thread. It shares a common memory area. Java supports concurrent programming through threads, allowing multiple tasks to run simultaneously within a single program. This enables better utilization of system resources and improves responsiveness in multi-user or multitasking environments. Distributed. Java provides tools and libraries for building distributed applications. It includes features like Remote Method Invocation, RMI, Java Remote Method Protocol, JRMP, and Java Naming and Directory Interface, JNDI, for communication between distributed components. This feature of Java makes us able to access files by calling the methods from any machine on the internet. Dynamic. Java allows for dynamic behavior at runtime. It supports features like reflection, which enables introspection and modification of objects, as well as dynamic class loading, which allows classes to be loaded into a running Java program on demand.